So, since we're talking about functions, arguments, parameter, we should spend some time to talk about the scope, right? So, scope, it matters a lot because you define how visible your variables are, your functions. Later on, we'll see this about classes and etc. But for now, think of this. If something is declared as in a global scope, means that everyone can see it, everybody can see it. And what we mean by that is any function or any call or any variable that is using that specific variable that's not defined in any scope, therefore it's in a global scope. And local scope is within a defined access, so it's inside a function, inside a loop structure, inside a branch structure or something like this. Like in this case right here, what we have is we declared a variable, and then in this case x equals 10, and then we use the function here, we define def foo and print inside foo x, and then we go there and take the value of x. But the thing is, there is nothing defined inside our function foo that tells that we have x, but we still can use this. Why? Because we go there and we access the variable that we just declared in the global scope. So what is happening here is at the execution time, we'll try to get the value x inside foo. You will not find it, and then it goes to the function scope, and then the global scope, and then whatever libraries that you might have. And here we have the path in which is described. So it first tried to look at the function scope, the enclosing function scope, the global scope, and the built-ins, right? So if we go ahead and run this, we'll see that either inside or outside our function, the value that we have for x is the same. Why? Because they are all using the same reference for the value 10, which is the object here, the variable x. Okay? Now with local scope, things are a little bit different. And why that? It's because even though we have still here something in the global scope, when we look in the local scope here, we have another declaration for the variable x. So in this case, when we printed out the information inside the function, since we have a different reference than the global one, our results are going to be a little bit different. So outside our function, as we saw it before, this is the same construction, we are printing out who? The global variable x. When we call our function, the full function here, it's using the local variable x equals 8. So when it goes there, it printed out x according to the value that we have. And after that, if we printed out the value after full, it's going to take the previous global variable. It doesn't matter if by the time we call this function right here, it's the local variable. Here is in the global. Okay? I think that the last example is more interesting because what we have here, we have two functions. One is reassign and then append one. And for both of them, we're passing the same list, but we're modifying it in a different way. So the first one, what we do is, after we receive a given argument right here, what we're going to do is, we're going to define this as 4 and 1, as a list of two elements, and then we're going to print it out that, right? Pretty much the same way we were working with the local scope. Then, what we're doing here in the other function is a little bit different. We're going to take whatever list we are receiving here, but we're going to append one to that list. So we want to modify the reference, the values in which that list is being referenced. So here we both are going to pass the same, we're going to pass the same list. So we're going to pass a list with one element right here, and then we're going to print it out the value for that list before the assignment, as we can see it here. And then we're going to call both functions, calling and passing as an argument the list itself. But then after that, we're going to print it out what happened with those lists. Okay, so let's go ahead and run this. So let's evaluate one block at a time. In the first case, before the reassign function, we pass a list of one element 4, and then we modify that list for 2 elements. So what I'm saying is here we have a local variable which is pointing out to this list. And pay attention to what I said. This is a variable that's pointing out to this list. It's not the actual list that we had before. And if we print it out, we have that variable as we can see here. But after that function, when we go ahead and print it out, what happened with the function that we passed, we have the original one. Why? Because the original one was not modified in the first place, as we have in the second example. The second example, whatever list that I'm passing here, we are passing here, I'm going to take that and I'm going to append an extra value to that list. So when we modify that, that's for good. So we are modifying the actual referenced list in the first place. So now so now we have a new value. Okay, so thank you and happy coding.